Good afternoon. I'm very happy to welcome you all to the data science seminar. My name is Meelis Kull. I'm associate professor of machine learning here at the Institute of Computer Science, and as the head of the Estonian Centre of Excellence in AI, I'm very happy that you have joined us for this event today, where we are going to discuss AI in action. So the Estonian Centre of Excellence is shortly called EXAI, and EXAI's mission is to do research in AI, but also to organize events to discuss more broadly the implications of AI in all of our lives in the society. And this is something that we have come to discuss here today, to talk about both the technical side of AI as well as the non-technical, and have a broad discussion. This data science seminar has a long history, many years, many events, but then this one is a special one in the sense that it's organized, the first that is organized by the EXAI Centre of Excellence. What we will have today is the excellent list of 6 speakers, and we'll hear from all the 3 institutions that make up the EXAI Center, which is the University of Tartu, Tallinn University of Technology, and Cybernetica. But we'll also hear from multiple companies, and some of the people have affiliations both at the university and at the company. Today, AI is moving very fast, and we are kind of constantly trying to keep the pace and try to at all times understand what is happening. All of us, I guess, more or less. And the challenge is that we need to kind of every now and then rethink about what AI can do for us now, and what is the best way of using it. And once we try to then implement it, what are the different problems that come up? And that's exactly what motivates today's topic, which is AI in action, success stories and lessons learned. So some of the talks are more technical, some are less technical. I hope everyone with your very broad background, 100+ people in the audience would get to take something important home with you. With that, I'm very happy to welcome our first speaker, and Tanel Alumäe, please. Tanel is from Tallinn University of Technology, one of the principal investigators at the EXAI Center. So Tanel is working on many things, but speech technology is one of those. Particularly, he's very well known for methods, AI methods that take speech and output text. And so his today's topic is about weekly supervised training for speaker and language recognition. So thanks, the floor is yours.
Thank you very much. The title is a bit misleading. I'm not going to talk about language recognition, but only speaker recognition. So as Meelis told you, our lab in Tallinn University of Technology is, well, maybe best known in Estonia for speech to text or speech recognition. But we are today I'm not going to talk about speech recognition, but speaker recognition. So who is speaking? And I'm specifically going to talk about weekly supervised training for speaker recognition. So to talk about weekly supervised training, we first have to understand that what kind of supervisions are there typically in machine learning. So if we take a typical machine learning problem, then we are usually dealing with fully supervised learning. That means that we have some training data, and all the instances in the training data are labeled or annotated by somebody, typically a human annotator. And the goal is to train a model that can predict the categories for unseen instances. In unsupervised training, we don't have the labels, we just have the data, and the goal of unsupervised training is to usually find some structure in the data, like clusters. In semi-supervised training, we have both labeled data as well as unlabeled or unsupervised data, and the goal is to typically also train a model that can predict labels for instances in the test set, but the goal there is to somehow learn to use this unlabeled data to make the model more accurate. In weakly supervised training, or also known as distantly supervised training, it is somehow fuzzy. And there are actually many different problems that fall into this category of weakly supervised training. And this weak supervision is usually used when full or this fully supervised data labeling is very expensive, but we have those weak labels already there, or they come very cheap. Some cases of weakly supervised training are candidate labels. So in this case, each training sample is assigned many labels, but we know that only one of them is correct, but we don't know during training which of the labels is correct. In probabilistic labels, each label is assigned to each instance, but with some probability. Crowd annotation also falls into the category of weakly supervised training because very often when we use like untrained crowd annotation, then the labels are noisy and we have to somehow deal with this problem. In label proportions, we know the proportions of the labels for a set of instances, but we don't know which ones precisely correspond to each label. And this last category probably best describes the setting that I'm going to talk about today. This last line here, it kind of sounds very abstract, but once you see the concrete example, then I think you will all understand what problem we are trying to solve. So in supervised training, fully supervised training for speaker recognition, we require training data for all persons that we are wanting to identify based on their speech. And training those speaker identification models requires data that is hand segmented. So if we have a long conversation of many persons, then we have to know that here is, for example, John speaking, here is Mary speaking, here again John, and only then we can train speaker recognition models that can identify, for example, John and Mary. And of course, producing such data is costly. And it's also difficult to cover a wide range of speakers. For example, when we want to build a media monitoring system that can transcribe, for example, TV shows or radio shows, radio talk shows, radio news, and which can also transcribe, so convert speech to text, but also assign speaker names to those speaker turns. And we would, in this case, we would like to cover thousands of politicians, maybe. Then we would need to manually annotate a lot of training data that covers a lot of such speakers. In weekly supervised training, we do not require time-based annotation. We only require recording level labels. So we need long recordings, for example, radio talk shows. And for each talk show, we just need to know that who spoke in that recording. We don't need to know the precise timestamps when the speech for each speaker occurred. And of course, producing such data is much easier, and sometimes, as we see later, we already have it based on some metadata. So the overview of this weekly supervised learning is given on this slide. We start with training data, audio files, and the corresponding speaker labels. Then we do speaker diarization, which I'm going to talk about soon. Then we do speaker embedding extraction. Then we do, this is the heart of the method, the weekly supervised training of this deep neural network model. And then the result is a model that can assign speaker names to speaker embeddings. All right, so a few words about training data. So for training data, we need many audio files. And for each audio file, we need speaker labels. But we need labels for only those persons that we want to cover with our model. Each audio file can also have other speakers who do not interest us. And of course, for each person, we should have many audio files, and there shouldn't be a case where a pair of speakers only occurs in the same audio files. For example, if there are, I don't know, podcast hosts that only occur together in a podcast series, then we cannot really tell them apart using this method. All right, so the first step is to process our training data using speaker diarization. And the speaker diarization is a technology that automatically discovers speaker turns in this long speech recording and clusters speech turns according to the speaker identities. So the input is a long recording and the output is such thing here. Speaker A, speaker B, speaker C, again speaker A, and so on. So this is a well-known method in speech processing, and I'm not going to talk about that for a long time. Instead, you should, I think I'll just skip it. You should assume that this method works. The next step is extraction of speaker embeddings. So this step maps each speaker, the speech of each discovered speaker, into a fixed size vector. So for all speakers, unnamed, we get one vector, and those vectors are typically 500-dimensional vectors. Again, the models for doing that are usually present. We don't have to train them. They are typically trained on very large data sets of speaker and speaker label pairs, but they cannot really name the speakers. They just map either long or short speech turn into a fixed size vector. So as a result of this step, we get this set of vectors. And the next step is training a neural network that can map speaker embeddings into speaker labels. that would be easy if in our training data we would have labels for each speaker embedding, but we do not have. We do not know which embedding corresponds to which speaker. So that's why we have to use this algorithm, which basically goes over all the recordings in our training data, computes the posterior probabilities for all embeddings of a single recording, then averages the posterior probabilities over one recording, and then computes the expected average. And finally, compares the predicted average with the expected average using KL divergence, and updates the neural network in order to minimize this KL divergence. So probably not many of you understood this, but I have a slide that makes it easier to understand. So let's say that we have a recording which has 5 embeddings. So speaker diarization discovered five speakers. And we have, for this recording, we have 2 speaker labels, John and Mary. Then the number of detected speakers is 5. For John and Mary, the expected average posterior probability is 1/5. For other speakers in the training set, it could be like thousands of speakers, the expected average posterior is 0. And for this model also has this special unknown speaker, which models sort of a background speaker. For this speaker, the average probability is 3/5 or 3/5. So here is a picture that makes it more clear. So we have those 3 speaker embeddings. Our neural network computes the posterior probabilities for all speakers. So let's say that our model covers 4 speakers plus the unknown speaker. For each embedding, it produces a probability distribution. What's the probability that this embedding corresponds to speaker A, speaker B, speaker C, speaker D? Then we average those posterior probabilities over one single recording. And we also know that true or expected average posterior probabilities. Those come from those labels here. We know that speakers A and speaker C are speaking in that recording. So that means that one of those embeddings has to correspond to speaker A and one has to correspond to speaker C. And one of them has to correspond to this unknown speaker. So now we have the expected average posterior probability, the predicted one, and we can compute the KL divergence and backpropagate to the model and update the model according to this backpropagation. And basically with this step, we say that the model should increase the probability for speaker A, decrease the probability for speaker B, and so on. So let's skip that. So what's the intuition of this method? With this method, we actually never tell explicitly to the model that which embedding corresponds to which speaker. Instead, for speaker A, for example, this neural network is encouraged to produce a non-zero average posterior probability only if this speaker A occurs in that recording. And in cases when it doesn't, when he or she doesn't occur in that recording, then the expected average posterior should be 0. And in the end, the only way for the model to satisfy this condition is to actually assign proper, not do the averaging as we tell it, but actually assign high posterior probability to an embedding if it thinks that this embedding corresponds to a certain speaker. And actually the model that maps embeddings to speakers is very simple feed-forward neural network. All right, so let's come to experiments. How well does this method work? This method was actually inspired by the fact that in the archive of this Estonian public broadcasting, there are a lot of radio shows that have speakers annotated in the metadata. So there are thousands of shows that have this speaker information here. And we were interested whether we can use this information to train those speaker recognition models. So we tested using basically almost 7,000 radio news shows from beginning of 2000s. For testing, we use manually annotated news shows from 2017. Our baseline is a supervised speaker recognition system that is trained on 200 hours of manually transcribed data, where for each speaker we have annotated the actual segments. And this baseline covers 800 speakers. But because we have a lot more data for this weakly supervised system, then this weakly supervised system is able to cover a lot more speakers, so almost 5,000 speakers. And this weakly supervised system can be tuned. Its recall and precision can be tuned. So, and we tuned this system so that it has at least 95% precision. And we can see that at this configuration, it outperforms the supervised system by a very large margin. Although it loses a bit in the precision, but the recall is like 3 times higher. We also analyzed that how many times a speaker has to occur in that weakly supervised training data in order to be identified correctly. And it turns out that those speakers who occurred 5 or less times in those 7,000 recordings, they were actually never identified correctly. So 5 or less times, it's too little. But if a speaker already occurred 10 times, then they were sometimes identified correctly. So those one here. And if a speaker occurred more than 15 times, then they were almost always identified properly. All right, I think I'll skip that. Basically, this weakly supervised system for speaker recognition is actually used in production in our web application that downloads radio shows from the websites of Estonian radio stations, transcribes them, and also assigns speaker labels to the speaker turns. So we see here a news show from a few years ago, and we see that a lot of politicians are here recognized correctly by their name. So the conclusion is that actually it turns out that this weakly supervised training for speaker recognition falls into a more general problem of multi-instance, multi-label learning that is, well, relatively well studied in the machine learning community. This multi-instance, multi-label learning deals with a problem that where we have where an example in training data is described by multiple instances and associated with multiple class labels. In our case, an example is a recording. Multiple instances are speaker embeddings extracted from the recording, and class labels are speaker names associated with that recording. And this problem has many applications in the domain of computer vision and other areas. And our future work is probably to understand that whether this proposed approach also works in the more general case. That's it from me. Thank you.
Thank you very much. Time for questions. As the microphone moves to the first one, let me ask, so we clearly heard a lot about success. I mean, you were able to make it work so that from just having shows with lists of names, you could actually take those names and put those into parts of the talk. What about the lessons learned? Anything that was harder?
Yeah, I can tell you about the problems. So the problem is the fact that it's not 100% precision. Sometimes in 5% of the cases, we associate the wrong name with a speaker in the radio show. And because our web application is public, then we occasionally get angry emails from people who say that, why is my name here? I'm not speaking, I'm not telling this bullshit. Please delete this. So that's the problem.
Okay, thanks. Question?
Yes, first of all, comment to Meelis. That's where you come in, uncertainty, right? About these predictions. I wanted to ask, so now I can go back into 2018 and see exactly what the politician said about this topic.
Exactly.
I can search the word, the keyword, and the person.
That's the goal, to have a speaker labeled and transcribed archive so that we can search both on content and the person who said it.
Very good point. So we hope a lot of new applications will be built on top of this. So this is really kind of foundational piece in potentially many applications. Any more questions?
More practical question on open source. How difficult is it for your group to maintain these solutions, like up to date?
It is difficult because we usually do not get funding for maintaining such applications, and we actually kind of fund this usually such things from new projects, which shouldn't be the case actually, but we kind of have to find like such ways to take care of that. So it's not easy.
Thanks very much. And now we switch gears to a very, very different topic. And I'm very happy to welcome Paula Etti here. I hope we'll get the slides in a moment, but she's from Cybernetica and has a quite different background from law and from e-governance technologies related topics. And the topic that she will be talking about is a lot more general. So yes, on one hand, we have data that are out there, but sometimes there are privacy issues and so on. And so therefore, it's important to consider the task of creating synthetic data. And we'll hear a lot more about that.
Thank you. Hi to all. I'm very glad to be here and share you my insights and my experiences with synthetic data and its role in AI systems. I am Paula Etti. I'm working in Cybernetica as a legal analyst, and I'm also responsible for the intellectual property management in the company. My initial experience with synthetic data was in 2000 and 2020 when we worked on a report about privacy-enhancing technologies for the Ministry of Economic Affairs and Communications. And explored how these technologies could be applied in Estonia. During interviews, the idea emerged that Estonia could have a synthetic twin for the e-state. And the concept is that each data registry would have its own synthetic version, enabling more efficient data analysis with stronger privacy guarantees by combining data from different databases. I kept thinking about the idea of synthetic twin and for the digital state, and when it came to time to choose a topic for my second master thesis, I wanted to dive deeper into synthetic data. At the same time, I was also involved in the project LAGO, which focuses on addressing the data issue in the research landscape for combating crime and terrorism. This led me to explore how law enforcement authorities engage with synthetic data, what potential they see in it, and what are the main barriers for the adoption of the synthetic data. And this June, I defended my master's thesis on the topic exploring the use of synthetic data in the public sector, a framework and case study based on the example of the Estonian Police and Border Guard Board. And to move forward with the topic of synthetic data, let me briefly explain what it is. Synthetic data refers to artificial data created in various ways, such as using real data, distributions, rules, algorithms, but very often AI and machine learning. When done well, synthetic data retains the statistical properties and patterns of the original data. This means that analysis on synthetic data can produce results very similar to those you get from the real data. And it's a method designed to protect confidentiality, and it has been widely used to preserve the privacy of the data subjects. It is a method designed to protect confidentiality, and it has been widely used to preserve the privacy while fulfilling the data analytics needs. However, synthetic data is a technology that is currently being researched actively, and we don't know all the answers yet to our questions. But each study brings us closer to the answers and a better understanding of synthetic data. Synthetic data is considered a privacy-enhancing technology, falling under the category of data obfuscation. Its main areas of application include privacy-preserving AI/ML and data sharing and analysis, and also software testing. Abdul Majid has further broadened the scope of synthetic data use cases in his article from last year. Also, the Singapore's Personal Data Protection Commission has highlighted several synthetic data use cases in its report from this year. As you can see, synthetic data is being used in a variety of situations. Technological developments in recent years have steadily increased the demand for quality data. Gartner estimates that by 2030, synthetic data will completely overshadow real data in AI models. On one hand, synthetic data helps train, validate, and test AI models, but on the other hand, AI technologies can be used to create synthetic data. Recently, synthetic data has become an important part of AI applications. The broad applicability of synthetic data is expected to make a primary resource for AI training. Many new generative models have been developed to fill the gap when good data is missing. And synthetic data created by these models is used in many areas like medical image analysis or diagnosis, language models, and image recognition. In this figure, you can see the process of using generative AI to create synthetic data. When data is processed using technology that qualifies an AI system under the AI Act, the data processor must adhere also the regulations governing AI. As you can see, the outcome can be synthetic tables, synthetic databases, synthetic graphs, synthetic text, or synthetic images. The use of generative AI models open up many new possibilities. Therefore, generative AI models are becoming increasingly popular for generating synthetic data. If you are using AI model to create synthetic data, it would be wise to take a look at the report published this year and created by Cybernetica, which addresses the risks and control measures related to the use of AI and ML machine learning systems. The report was commissioned by the Information System Agency, and there are also some videos online based on this report. And making videos on a green background was a very exciting experience for Cybernetica employees. And now something about the lawyers or legal background. The legal nature of synthetic data depends on whether it is considered anonymous or pseudonymous. Therefore, it is important to assess the level of privacy of synthetic data. Everything depends on the purpose of synthesizing data, what we aim to achieve, and how much privacy is needed. It also depends on the sensitivity of the original data that we need to protect. And challenges persist. While synthetic data can lower privacy risks, re-identification is still possible if records, attributes, and trends from the original data appear in the synthetic data. Additionally, like anonymization, synthetic data can be vulnerable to attacks and doesn't fully protect against revealing certain attributes. Anonymization isn't always achievable or permanent. We need to take into account also rapid technological development. Therefore, the privacy risk should be managed over time. And depending on the situation, you need to consider how much privacy is necessary. This figure illustrates that typically the higher the privacy level, the lower the utility of the data. Utility in the context of synthetic data refers to how useful or effective the data is for a given purpose. For certain goals, higher utility is necessary, which means privacy guarantees may be lower in these cases. Balancing these two factors, utility and privacy, is key when deciding how to use synthetic data. Depending on the use case, we might need to make trade-offs, always keeping in mind the sensitivity of the original data and the goal we want to achieve. When the general trends or insights from the original data are sensitive, organizations should remember that using synthetic data won't protect those trends or insights, as they can be replicated in the synthetic data. If the synthetic data is intended for public release, organizations may need to prioritize data protection over data utility in these cases. Now, returning to my experience with synthetic data. As I mentioned before, I researched the use of synthetic data in law enforcement authorities. They have lots of challenges in data processing. They have legal concerns, privacy and security issues. They have very sensitive data, like personal data and tactical information, and they have data sharing limitations. And it has all affect the collaboration efforts and innovation. And the potential solution can be the introduction of synthetic data in the law enforcement authority settings. My hypothesis was that the use of synthetic data in a law enforcement authority ensures better protection of sensitive data and improves the efficiency of the authority's processes. And I formed also 3 research questions. My research methodology consists many parts. I did secondary data analysis. It was necessary to define theoretical and legal framework and also identify possible uses of synthetic data in law enforcement authorities. I also did empirical data collection. I conducted semi-structured interviews and did expert surveys. I interviewed 4 people from the Police and Border Guard Board, 1 people from the Ministry of the Interior, and 1 people from the IT and Development Center of the Ministry of the Interior. And experts were from the Data Protection Inspectorate, Ministry of Economic Affairs and Communications, and also from Cybernetica. I create privacy notice that is available in the Appendix 3 and also created business process model notation for the process how Police and Border Guard Board disseminates data. And I also did statistical analysis and data synthesis with open data to just demonstrate the process of creating synthetic data. And this allowed me to create a framework for implementing data synthesis in an organization. So, the outcome and findings. The first research question was how do law enforcement authorities currently deploy synthetic data? And the key findings was that they use it in the crime data analysis, statistical analysis enhancement, and procurement process support. The second research question was which processes within law enforcement authorities currently hold the greatest potential for the utilization of synthetic data? And they see the most potential in developing and testing IT systems, educational context, simulations, synthetic twins for databases and research. However, there were some kind of skepticism regarding complex researches. And the third research question was that what are the key barriers to adopting synthetic data on a larger scale? And the most important barriers were legal restrictions, for example, lack of suitable legal basis and legal nature of synthetic data. And the second was the maturity level of synthetic data, which requires further research and lack of certified synthesis tools, and also limited knowledge of data analytics and synthetic data among people in general. To implement synthetic data in an organization, a structured and methodological approach is necessary to maximize effectiveness and ensure compliance with legal requirements. Therefore, I proposed a detailed 6-step framework for integrating synthetic data in an organization. And my conclusions were that all parties were interested in the implementation of synthetic data. The findings just suggest that synthetic data can significantly simplify internal procedures and support the development efforts in law enforcement authorities, and identified obstacles need to be addressed for the wider adoption of synthetic data. And recommendations. Firstly, we need to agree what are the main criteria and principles of using synthetic data, and in which circumstances or cases synthetic data can be created based on personal data. Second, we need thorough analysis of synthetic data across multiple sectors for better understanding its implications and benefits. And third, to have wider adoption of synthetic data in an organization, we need trainings and workshops regarding synthetic data and data analysis, and also pilot projects with synthetic data to increase knowledge and competence within the organization. This brings me to the end of my presentation. Using synthetic data in AI helps to improve model training, increase data variety, and protect privacy. As AI grows, synthetic data will be key to building better and more reliable AI systems. However, you have to keep in mind all the limitations and prepare a proper risk assessment. I hope you find some new ideas and some new reports to read. And this is it. Thank you.
Time for questions.
If you create the synthetic data so that it simulates the real data, wouldn't it have the same problems as the original data, that it's not worse, it's always the same kind of data, so you run a problem of not having different kinds of data?
Yeah, thank you for the question. It can have the same problems as real data or source data if we find if it's like with maximum utility synthetic data. But the synthetic data is created for that it's like replica of the original data, and when you have the right methods, then you get something that it isn't real data, and you just have to set your parameters, taking into account purpose, what you have, what you want to do. Yeah, it's complicated, and as I said, we don't have all the answers yet, but we are doing research, and also we are doing research in Cybernetica, and we want to know more about synthetic data, and we also want to create tools for the wider use, if I don't know anything about synthetic data, I just have the tool, and it does not everything for me, but I can check what I want to do, and it helps me a lot. But this is idea at the moment, but we are creating a pipeline, and we are researching how to do that in a best way to help people and help companies and help our government.
The relationship between synthetic data and AI, in a way, is bi-directional, because on one hand, maybe you want this synthetic data because you want to train AI models, you want to, but you have very little real data, or they are very privacy concerns, therefore you cannot use the real data. So that's kind of a use case why you need synthetic data for AI. But it is also the other way around. So if you want to generate synthetic data, then that's a hard challenge. You want, as you said, you want to make sure that the statistical properties of the data are retained, and that can be very, very hard to achieve. What's your view on kind of putting this all into use, into practical use? What are the roadblocks? What are the things that are particularly hard at the moment? I mean, you had this kind of nice pipeline of what you wanted to, what the kind of way with 6 steps could be towards putting it into use. But where do you think we might run into trouble? I understand, of course, that there are laws and regulations, but from the AI side as well, the hard challenges. Have you looked at all yet with Cybernetica into the AI methods that need to be used to generate the synthetic data?
No, not this. One moment, I'm gonna find the chart. There were a lot of questions. Yes, this one.
So this is the 6 steps.
Yeah.
But now, in trying to make this happen, where are the roadblocks, and particularly related to AI?
I think there are a lot of roadblocks on the way because it depends also whether I deploy someone else AI systems in-house or whether I'm creating new AI system myself. We have all the materials written in the AI report, and I recommend to read it. And I think there are hurdles in the first step also how to define the right purpose of the processing. You have to evaluate the legal landscape. You have to have legal knowledge for that to assess all the relevant legislative acts and norms, and you have to do risk assessment. It isn't very simple. Also, you have to, in the step 2, you have to collect the data. Where to get the data? Do you have the necessary data in-house, or do you buy it somewhere, or you create it, or you synthesize it yourself? And also data pre-processing, you have to clean the data and do different things to have like quality source data. Because if you don't, then comes bias, and then comes everything that you don't want to have. And the method selections, we have a lot of methods, and they are all researched heavily at the time. I think it would be good if someone like wrote or gives you guidelines. You have this kind of case, and then this method works the best for this case. But we don't have this kind of instructions yet, but I think they are going to be there in some time.
So it's relatively early days in
very early.
making it all happen.
Yeah, and
more
all
questions.
Thank you. Thank you for a really interesting presentation. I have a rather naive question. How big is the danger related to synthetic data? And what I mean by that is, how easy is it to detect synthetic data today, and let's say in the future? So how big is the danger that, say, we might be flooded by synthetic data, and we cannot tell real data from synthetic, which might sound like a naive problem, but in some cases it can lead to some pretty bad consequences.
Yeah, I want to show you how big are the risks, but I can't, because it depending on the project, on the scope, what are your methods, why are you doing this, what data you are using, whether you're using medical data or financial data or some kind of it depends on so many aspects, and we don't have a single guideline for data synthesis at the moment. I think we don't have it in the coming years also, but we are doing research, and we try to find the right paths and maybe analyze some cases further, and to have some results that we can publish and share our knowledge with you guys.
But in particular with large language models, these can generate data, right?
Yeah.
So this is also synthetic data. So if the internet gets flooded with synthetic data in the sense that these are, I don't know, reviews or texts or new pieces of news that are actually all generated by large language models, is that an issue that kind of relates to your work?
Yeah, I had two thoughts. One is the copyright problem that we have at the moment, and when the data is generated by AI, it means that there are no author, and you can like freely use it if it's published on the internet. And Yeah, but if we have synthetic data created by artificial intelligence, we have to be very careful because there might be bias, there might be a lot of things that we don't know, and we have to be careful what data we are using in any of our decisions, and it's very important to have proper data. And if you are doing it yourself, you have better control over it.
One last question.
Yeah, you mostly were speaking about like data, synthetic data for privacy, but I was thinking in terms of like data augmentation. Let's say you don't have enough data and you want to synthesize some more, but how do you know that you have enough data that it captures all the connections or relations in there, that you don't just synthesize some huge amount of data, but it still doesn't capture the essence? Or like, what kind of tools can you use to make sure that you have enough data?
I don't know, maybe some experts know know more what kind of tools you have to assess, but you have to like set the parameters and check the parameters whether they are suitable for you, and yeah, yeah, you have to measure it somehow, but I don't know at the moment how. Yeah, there are different techniques how to measure it, but you have to like choose the measures according to your certain cases, and it could be different case by case.
Thanks very much.
Thank you.
And next we will hear from Kristjan Eljand. Welcome. So he's from Andmeteadus OÜ, and Andmeteadus is data science, in case you didn't know. So there are loads of companies that want to do AI or think they want to do AI, and there is really a lack of experts in this field. So it's great that there are companies who really know this stuff and can consult and make AI happen in practice. So Kristjan will talk about how Estonian companies have so far implemented generative AI, and the floor is yours, please.
Thank you. Do you hear me? No? It's good? Okay, so my name is Kristjan, and I think that we should start from where we were left, kind of, because if anybody these days tell you that they are dealing with generative AI, and especially if somebody says that somebody is an expert on this, then some background is needed. So my background in AI is that I've been in the field for the last 14 years in the field of data science. And during this time, actually my background, my education is from economics and business. And the first hints towards like training something, maybe also given by Andres Võrk, who is sitting here. And one thing when I entered the field, one thing that always felt somewhat uncomfortable for me was the fact that we always needed to start the AI project from building the oven ourselves, meaning that we needed to first build something where we can put the data and to start cooking something. And many discussions in the lunch table kind of focused on hyperparameter tuning and stuff like this. And where I felt uncomfortable was that we are kind of trying to cook something for the business, but we are talking about the details of engineering the oven. And generative AI, and especially the GPT 3.5, changed this. Of course, I was keeping the hand on the pulse of this even from the GPT-1, and GPT-2 was amazing already and so on. But yeah, it really changed the game, because now the warehouses are kind of full of ovens. We can select whatever we want. And the challenge is a bit different. So now we can focus more on really dealing with the business problem itself. And this is like interesting perspective, and that is the reason why for the last almost 2 years now, we have focused with our little team on building custom generative AI solutions for organizations. As I said, a little team, but I guess we have done quite a few projects. And I will try to show you some of those projects. What was the problem? What was the solution? I can't go really into much detail on some cases, but let's hope that it's useful, and I hope that I'm also able to give you some angles maybe that you haven't thought about. So the first kind of the problem statement or the set where I see that we have done and that is worth sharing is that Enefit and the city of Tartu. So information retrieval chatbot for employees. So one thing that changed and has changed is that now it's pretty common that chatbot has some ability to kind of access the information, the underlying documents, and to read something from there. Not the chatbot itself, you first kind of find the information and then put it towards a chatbot. The method is called Retrieval-Augmented generation. I know that Elena is talking more about it later, so I won't tell you too much. But the problem itself, Enefit and City of Tartu, very similar problem. Over the years, both organizations have accumulated like thousands of documents and containing procedures, rules, guidelines, and there is some idea there that employees should be aware of all of them. And of course, in real life, they aren't, right? Especially like new employees, they don't know anything about it, and nobody really goes into reading those documents. They are not regularly saved in nice places either. So the data, procedures, guidelines, rules stored in SharePoint, Confluence, a company's own document repositories. In Enefit, the project potentially 4,000 plus users, employees. At the city of Tartu, roughly 100 users. Actually, I guess that it might expand to a little bit more than 350 users. Then when the first project, I kind of was able to kind of be at least the project manager, was the Enefit project, and what I wanted to do there was kind of try to measure the potential value. And what I did was that I asked 63 employees to kind of measure how long it takes for them to find answers to the questions, company-related questions. And the median value was 18 minutes. But it had this interesting long tail as well. And what I find interesting was that 15% of questions, finding answer took more than 2 hours. And the process didn't go like this, that a person tried to find the answer for 2 hours. No, they kind of tried to find an answer, they didn't find it, then they bounced it forward to the manager. And then manager answered or didn't answer in 6% of cases, and then the employee sometimes even like just told maybe that, okay, that it's not worth my time, and this information is not so important. So this is the basic value statement anyhow, that you save some time, you maybe save the focus and time of your manager, and maybe you get some answers that otherwise you just stay in dark. Now, the second use case that I want to share, Universities of Tartu use case, and why I bring it out separately, I see it as a little bit different thing. The Tartu Linn and the city of Tartu and Enefit use case is what I call kind of like a wide and shallow use case, meaning that the document types and document kind of content is very wide, starting from strategy, ending with, I don't know, rules for vacation. And it's shallow, it doesn't do much, kind of, also it answers questions and kind of links the document. Now, with University of Tartu, we participated in project information retrieval chatbot for IT support. So the problem, university's IT support has created a bilingual guide to help students and faculty find answers to their IT issues. But, and the document base is not too large, it's 700 documents, but still, it's pretty good document base, but still students, when they come in September or whatnot, they still send very trivial questions towards IT support. So IT support still needs to handle this. So now they have created a very nice resource, but still need to handle the trivial questions as well. So here we try to kind of create like a chatbot, and where's the kind of the angle here is that now we are focusing on very specific field. We try to help IT support specialists to kind of take off some workload from them. And the problem statement, I think, is even clearer, and that's maybe the reason why I like it. So potential users, 14,000 students and 3,600 employees. Now, let me talk a little bit about like how this kind of solution works, for example, University of Tartu. So when you touch it, you feel that, okay, you send a question and you get some answer. But what really happens is that user asks a question, then in the second step, actually, we first validate the question. Whether we can even start answering the question, or is it some sort of hijacking attempt or something like this. So whether it's safe or not, right? Then the third step is semantic search, or rather a search system, where we try to take the question or the chat and try to find the relevant pieces of information that potentially can have answer to this question. And it is a little bit more tricky than just semantic search. It contains more elements, including like using the more like keyword-based search, like hybrid combination of semantic search and keyword-based search, plus also neural re-ranking of the results for a little bit better results. Then these documents with the question are sent to the large language model, which generates an answer. Then we log the question and answer for analytics, and the answer is then modified into the suitable format. So quite a few steps before the answer is sent back to the user. But this is not all, and my statement here is that all GenAI solutions, not only chatbots, all GenAI solutions without testing and analytics are pretty much like party tricks. You are pretty fastly, you are able to show something, but actually you can't implement them inside your processes like this. So, first thing, testing. Okay, now we have this fancy chatbot. What's the quality of this? What's the quality of the answers? What's the quality of this information retrieval? It's a non-trivial challenge to actually calculate these values because we are dealing with unstructured answers, right? But it's possible, and when systematically implied, you can calculate the accuracy of the answers, semantic similarity. You can also calculate the information retrieval quality, how much information you are able to find, and these are your main guidelines of developing the solution, actually. Because first, what you want to do, you start developing like this, that, okay, you see some like question where you don't get a good answer. And now you start to tweak your prompt, let's say. And then you get the good answer to this question. But maybe the other 20 questions that people want to ask just received like worse answer. So you can't test it like this. Of course you can, but it's not like, it doesn't fly in the long term, right? So you need to have something systematic in place. And then the other thing that I want to mention is the usage analytics. So imagine that now people start to use this chatbot. And actually there is like a very nice information in there, right? And we can log these questions and answers, anonymize them in the way. And what happens really is that we now have a perspective of kind of like integrating this thing into our information management system in a little bit different way. Because now what we are able to see is that what our users really want, what they are really asking, and for what they don't get good answers. And this is the signal back to the document owners of what information I need to create, right? So that, for example, if users are asking about internet and they don't find answers, we can check what are these questions that they don't get answers, whether chatbot is stupid or whether we don't have the document actually there, and we can now create this document or enhance the document. In University of Tartu case, actually, the current situation is also a little bit interesting, because University of Tartu specialists made very good job giving us the topics, what they want to map, the questions, and we see that 40% of the questions are mapped to the other topics. So, but it's also like nice, right? Because now you see that what students and faculty members are really asking. Of course, they try to hijack the thing as well. But these are students, we expected that. Okay, but now let's switch gears. Let's switch gears from the chatbots to something else, because Gen AI can do a little bit more than only chatbots. It can also do analysis and comparison of different like unstructured data. So for example, easy insurance problem. When a client asks about insurance terms, the specialist has to either rely on their own knowledge, search for the answer in insurance terms, or ask a colleague. So easy is kind of like middleman between different insurance companies. So you can ask about 10 different, you ask a question whether this is covered, but the answer is in 10 different like insurance documents. So memory can fail, searching through insurance terms takes time, and asking a colleague consumes their work time. So the data is insurance terms from various insurance companies, users approximately 40 insurance specialists. And the end result looks like a chatbot. It has a chatbot interface, but actually in the background something different goes on, because now we are not only doing like the regular question answering, we are actually going in the loop one by one, trying to find the answer from different companies, then put everything together, analyze them, and then give the answer to the kind of the specialist. So if they ask the question and select the insurance companies for what they want to get an answer, then the answer is put together in such a way that for company ABC, the answer is like this. The company something else, the answer is different. Now, the key challenges in this project was that data is complex. Insurance data is really complex. And pre-processing plays a crucial role. And this also showed that, like, currently one could ask a question that who needs data scientists these days, but actually you still need them, because you can get a lot more higher quality if you pre-process the data and enrich it with metadata, for example. Because in insurance document, on the first page, you can get something that this is covered, and the last page says that, oh, but there is an exception that we didn't mention on the first page. And then one more use case, what I want to share, I can't name the company at the moment, but it's about automated information extraction. So there might also be a use case where you have a documents, unstructured data, you want to turn it into structured data. So, for example, company specialists have the process of large amount of unstructured text. They need to process many emails, documents, and need to take some pieces of data and fill into the sales system or some other system. And it's there are roughly like 20 to 60 fields that needs to be filled in. And it doesn't take too much time for specialists, roughly like 5 minutes, but there are so many of these cases that it's still like worth like automating. And approximately 200 specialists across Baltics. And so the solution was that we can potentially do it with Gen AI. So we built like a REST API that accepts unstructured documents as an input and extracts the agreed upon fields in a JSON format. And it is kind of solved in a divide and conquer way. So field by field, you go, try to extract it. Each field has its own like prompt, what to extract. And actually, when the result is returned, we double check whether it matches the data format that it needed to match. If it doesn't, we send the error message back to the language model and ask it to do better. And it actually is able to correct it on many instances. So summary, first, RAG-based chatbots that help employees to find data. Then, secondly, the chatbots that are kind of assisting specialists on more specific field, some more specific use case, and maybe even the user interface can be specific, because some specialists might need, maybe they want to see something else. Like. Then thirdly, we as humans are not very good at extracting information from unstructured data. We are doing it daily, but not because we are good, but there just isn't the technology that can do it. And but now there is pretty much, and let's leave that to the machines. And then finally, generative AI can also help to compare and analyze texts. And there is one key right there, what generative AI brought into the game, what pre-trained generative AI. We can now deal with unstructured data. Beforehand, we have all the things for structured data. Now we can also deal at least a little bit with unstructured data. And that's it from my side.
Thanks very much. Can I see hands? Yes, my microphone is on the way. But while it's going, large language models, open, closed, from the cloud, on-prem, locally installed. What are the ways to go?
So we want to avoid open source and locally installed models currently as much as possible. And the reason is that we kind of want to use the possibility, we want to be able to kind of take the value from the competition that is happening amongst large players, meaning that whenever somebody comes out with a better model, we will be fast to kind of switch it on. We can enhance our projects without doing anything pretty much. With local installation, you always are in a more like hands in there, and you need to care more about what's going on. And
so, have you shifted already to 01?
We have tried. Actually, today we were open the API because it wasn't like kind of available for all kind of usage tiers. Today we were open this, but I am very careful of using this in the client projects because it is very like hungry.
It costs a lot, yes.
Yeah.
Hello, hi, my name is Kirsty. I'm an IT analyst. I have a question, maybe it's quite specific, but the question is about the human hours that it takes to get those systems working, training basically. So can you put that into perspective? How many hours, how many human hours it took to get let's say, the Tartu University project kind of working at like a good level? Thank you.
I don't know, honestly, but it's the least that it has ever taken, let's say. So the barrier is smaller than it ever was, especially because we can stand on the shoulders of those large language models, pre-trained large language models, before the first 12 years, we always needed to first start building this oven. But I would say that you can. What has happened is that, and there is the illusion that everything is now very simple. That what is kind of simple today is that first 70% is kind of simple, but the last 30% is still pretty hard. And I always say that we have this line of utility in our minds. We don't know exactly where it is, but when we test it, we know it, and it's pretty binary. Everything that is under this line, we kind of label as a shit, especially Estonians, and everything that is over this line, so it's worth looking into. And this line, I think that it's somewhere in 95% of accuracy. If you get less than this, if you get 70%, then nobody is starting to use this solution. So the first 70% has gotten a much easier, but the last 30% is still pretty hard. But yeah, it's better than it ever has been.
Hello. Can you please elaborate on the third example? Like, what's the accuracy level that you get there? And what are the biggest challenges? So by the third example, I mean the email and PDF stuff.
Okay. So there, when we started, the first version that we did had roughly like 60% of accuracy. And then the current version has 98.2. And actually, we kind of thought that maybe 98.2 isn't enough, because we want to extract like structured data and put it into the system. But we realized that it is enough. And we realized that it is enough because when we got the ground truth data labeled by humans, then we found that we have some mismatches between ground truth and our things. And when we looked them over, then we realized that actually the ground truth data was mislabeled. It was taken from the current system. So, and we found out that actually people are currently doing more mistakes putting data into the system than the AI does, because people have different styles of writing the same thing and so on. So the 98.2 is enough because people are doing more mistakes.
There was a question there.
Yeah, if you're using like the cloud-based installations or public APIs of large language models, how do you solve the confidentiality and privacy issues?
So it's always use case dependent, right? So in some use cases, there isn't too much of these. The data that we are dealing is maybe public anyway. But if the use case is more like, let's say, needs more like security and stuff, then where we have currently gone is more like OpenAI or Azure OpenAI service, where you can kind of, if you trust Azure or if you trust Microsoft, or if you already are in, if your data is already in this Azure cloud, then we can tell that, okay, it stays in the same cloud, and you get your own model instance, which nobody else can turn to. And for some cases, yes, we can't use the cloud, and so the project can only happen locally. We haven't taken those projects on currently.
Thanks very much.
Thank you.
And now there are snacks and drinks up there. Don't then go away and come back very soon in 5:45, so it's in 18 minutes. We'll be back here for hearing about companies doing a very set of interesting things. So see you soon. Okay, welcome back. Data Science Seminar, AI in Action. We are going to hear 3 more talks. People from companies, some also co-affiliated with university. And we'll hear about 3 different perspectives on how AI is put into use. And I'm very happy to introduce the first speaker, Martti Praks. So he's from LHV. He also has graduated from here, from University of Tartu, Institute of Computer Science.
Exactly.
So we'll hear about how banks see the use of AI and how they put it into use. Please.
Thanks. I'm not sure about that I know all banks, but I do know what we are doing in LHV. So yes, hello everyone. I'm Martti Praks. I'm responsible for developing AI systems in LHV. My presentation here today is not very technical. It's more about, let's say, organizational problems, because that's something that I tackle every day, as my task is to try to find this business value from this technology and how to do that. So let's talk one story. Once upon a time, there was a bank, an Estonian bank. It was fairly successful. It grew quite rapidly, produced good results. It was fairly technical. The technology basically was in its core because it believed that providing good services in today's environment can be mainly done via technology. So mobile bank, internet bank, this is all very important. This bank, I do need the notes, sorry. EXAI, and the bank was expanding quite rapidly. They started their, let's say, sister bank or another bank in the group in UK. This meant that all the technology that the bank had been using for many years, it got some update, meaning there were new ideas, how the core systems were built, and these ideas spread to Estonia as well. And the world around this bank had many developments in AI technologies. So the buzzword AI was was expanding rapidly, and so in the bank, many people started to ask questions like, are we doing enough? Are we actually using this AI technology, since technology is in our core? And can we do something more? Can we do something extra to not stay behind in this technological race? So there were some key events that happened. Firstly, senior management. The owners, the board, the high-level management thought that, okay, we need to do something a bit differently than we have done so far. And they said that AI now is something strategical for our company. We want to do something different. So there were people hired, consultants who helped set up some new processes, do some new stuff. On the same time, there were employees in this bank, experts in some field, who said that, okay, we're not really using machine learning, data science, perhaps in some cases, or let's say LLMs in general. Can we do something differently? So they created this thing called chapter. It's basically a small group of people for us, which takes responsibility from some problems, and in this case, how to use more AI technologies. There were changes in there was an evolution in the technological stack. So basically, there were new opportunities to do things differently. What I mean here mainly is cloud computing opportunities. And I've left out one key piece in the story of this bank. The theme, the creation story of this bank includes this myth, if you say, that the bank itself is a pirate ship. So basically, they're ambitious. They want to do things differently. They don't want to be content with what they already have. Perhaps let's just keep in mind this is still a bank. So the main ideology that the bank is providing is trust and security. So there are definitely confines into that idea. But moreover, in this trust environment, banking sector has been existing for more than many hundreds of years already. So you need to be ambitious and try new things, and a pirate ship is a good theme for that. So, with all this in place, what happened? First action was ChatGPT for all employees, meaning here. The idea here is that instead of buying some new service, some, I don't know, access to some LLM via some cloud service provider and trying to implement some solution on their own, we wanted to provide a tool for all the employees to play around, to be more efficient in their everyday work. So yes, initially there was like a selected group of people who got this access, but for now, and like a few months later, then when this ChatGPT was introduced, everyone who wanted access got the access. I think this is also, if talking about risks, I think it's a better way to use ChatGPT enterprise version, because in this sense, you at least have a promise in contracts that the data is not used for training. And this way we have like, there were trainings for employees, there were guidelines how to do that. So we are trying today on top of this topic and use artificial intelligence securely. Train our people instead of just saying you cannot do anything. And I guess soon enough, when people started to use ChatGPT, it became quite apparent that it's basically just a gateway, if you will, a gateway drug, that it gets you hooked, but you want something more. You need to do something more on top of this to get the benefit. So for my job, it's actually quite useful because people who are using ChatGPT start to understand what it actually can do, much better than people who haven't done it, and they are more better to describe what they need extra that the ChatGPT is possibly not providing to them. So I will make a pause in that story, as the story is still being written. We don't have dragons, we don't have treasures, there are many things to come. It's a bit early to do long-term conclusions, what has been going on, but I think I can share some struggles that we have had with in this journey so far. So how to be innovative? As a bank, as a very large enterprise, it's very difficult because the regulations telling you what you can do and what you can't do, There are so many. Understanding all of them, I think Kristjan previously mentioned something. It's a very difficult problem, but you need to still be compliant. You need to understand them. It's quite old industry. Many ways are already discovered or done. It is a difficult problem for a bank like us, how to be innovative. And what helped us a lot is support from senior management. I think the culture, this pirate ship theme that I mentioned, it's really useful. Means the company wants to be innovative. Of course, it's also helpful if you have champions in senior management to see that this is an important technology where we need to do something. With this in place, I think next step is finding good ambassadors, experts, if you will, in the topic, who understand it and who can be ambassadors inside your company, telling people this is how you can do better, this is how you can try, this is what you should be doing, and so on. So like mentors, for example, for the people trying out new things. And lastly, I think you just need to deliver good results with the projects that you start. And they actually give the confidence in that new technology. And that fact that being innovative has been good, helpful. Okay, second struggle, where to get this talent? I think this is a very common problem in Estonia and in AI for sure. The way we have approached it is that I think the services available are quite mature. It's quite easy to just pick some pieces and add them together. Like Kristjan said, you can go 70% of the way, get some results. And this can be fairly easily done by software development. So the existing knowledge that we already have inside our house. Of course, yes, to get better results, build better models, we also need data science and AI experts. So we need to hire experts here, but the starting point, I think, is fairly low already. And you can reuse your existing knowledge. And to be honest, in my opinion, building some kind of AI system, most of it is still software development without any special needs to know data science, for example. And yeah, I think regarding talent, like always, growing the skills of your people, I think this is very crucial for any type of talented work. Third struggle. Okay, you have a bush, you have the people, what to do? What are the projects where to put your time and effort into? How to select those? So I personally trust and use a lot of these domain experts, because I think one of the worst things to do is to try to solve a problem that is not worth solving, that is not helping anyone. And in this sense, I think the domain experts are the best ones. Of course, yes, you read what is happening in other companies in the world, you see the other use cases, but in the end, you need to be sure that the use case that you're trying to solve with any tool that you're using is actually worth solving. Yes, if you have those ideas, where to work on, next step for me is to prioritize. So all ideas are good, but you pick the most important ones that support your company goals. And collaboration, it's important to deliver those projects well, but I do think it's also important when you need to select what projects to do, because those domain experts, stakeholders, the team, and most important, the customer, they all need to understand what are we actually doing and how we are trying to solve it. So with all this in place, so where is this AI that I'm talking about, this mythical thing, basically? I think prototyping with this technology is very quick, but in the end, if you want to deliver something, you still need to put in a lot of work. I think even more possibly in some cases than previously, or when you try to develop some system, because you have extra layers, extra complexity, and it just needs time. All this being compliant, what data can you use? Do you actually have good quality data and so on? So this just needs effort and time. I believe in following big ideas, but you need to be sure in the steps that you're doing, so master the tools that you need in order to follow those ideas. And that's why we have mostly started from these internal and supportive tools to understand the technology better and provide some value. And once we're comfortable enough, then we will probably deliver some things that you can read and use yourself as well if you are LHV customer. Because in the end, we all want to work in a company that provides this futuristic technology-based services. We want to make our customers' lives better. We want to help them provide value and get better access to money and resources via this banking service that we are providing. That's it. Thank you.
Martti, what is the most challenging aspect of starting this AI project in the bank, which is a very strict organization?
You mean in general or in LHV? In LHV, I think we had senior support in place, so that perhaps wasn't that difficult for us. I think out of these struggles, I would name it finding good talent and trying to incorporate the good people into our team.
Thank you. I have a question. You focused a lot on the ChatGPT, sort of chatting and asking questions and getting ideas. And your story was saying that we want to build a bank that, not you, somebody wants to build a bank that is innovative, provides new ideas, new services, innovates throughout. But ChatGPT is so existing data. All these ideas have been there somewhere. It does not necessarily even provide you any totally new insights or ideas. It's reusing something that is existing in the material. So how do you explain this problem? Like you need to innovate with the totally new, but yet you only recycle the existing ideas. Or am I correct or wrong?
I think you're totally correct. ChatGPT has been existing for years already, right? But this is, let's say, one of the stepping stones to start. And I think from the story, it has helped many people better understand what is this AI that we're talking about. So that's why I think I want to bring it out as something important, as we really are quite heavily using it for many people. And I am not that aware that many banks are doing the same thing, at least not officially. Perhaps unofficially, for sure, but not officially. But otherwise, yes, I really didn't talk about many other ideas because I don't want to talk about things that really haven't been delivered and can be talked about publicly while they're being delivered. So that's why I think today I mostly focused on one of the ideas.
Hi, I have a question maybe about quite specific now. I'm assuming that AI could be used in risk management in banks. Machine learning definitely, if not AI. that way, generative. Is any of that used in risk management in LHV? And if so, could you maybe elaborate a little bit? Thank you.
I think there is a question about what do you mean under AI? Because risk management for sure, definitely important topic. And I think for many years already, different tools have been applied from machine learning and building statistical models and so on. So I do think in a wider sense, AI has been used for many years already in that domain, in LHV Bank as well. But yeah, if we come to like some people outside this room mainly, I think, put equal sign between ChatGPT and AI. So let's say large language models and AI. There we are building few tools. I think trying to solve the problem of having much of this text-based data and providing insight into it is a fairly simple first step that we actually are using in live as well. And I do hope that we will get to continue this track and implement those tools in general in other domains as well, in risk.
Thank you. I love the fact that as I'm a client of LHV, I'm also a little pirate. But to the question, I wanted to ask a very specific question about onboarding. I think onboarding is the biggest problem of implementing AI tools in companies. And the question is, you said you had trainings and sort of that part of onboarding. Did you go specific in terms of different departments had specific trainings, or was it general? And do you think it was an effective method to do onboarding?
Thanks for the question. I think that is a really difficult topic. We had a fairly general introduction for all of the departments, because I think we mainly focused on the risks and limits. For sure, no, ChatGPT, you cannot add customer data and very sensitive data there. So that's basically the level that we were mostly focused on. Otherwise, we did some, let's say, inspirations where to play around it and try. So yeah. But this is, I think, a very complex problem, and actually I'm trying to update our training program and perhaps get some new insights.
Okay, so for many companies deciding whether to go with ChatGPT, the main question is, since you have adopted ChatGPT, has the volume and cost of mistakes gone up or down?
As we're using it inside like work process, it's a tool assistant, if you will, to employees. It's very difficult to measure. So how do you measure that there are more mistakes? I don't have official statistics to give. And my personal opinion is that no, it hasn't gone up, because I think people are fairly like self-aware when they use this product. Of course, the first question is just like play around and get some answers, but if you start digging in and start actually using it, it's not just that you get some ready-made document, you get ideas, you get discussion, you get feedback, and you build on top of this. So I actually think in general it should produce much better results than just asking and getting some simple question where you might have errors in.
Taking AI into use, there are many things that can be done. Many tasks can be either automated or humans can be assisted in various ways. Well, I guess you're taking kind of prioritizing that long list of things that could be done and try to kind of take the first wins quickly. And so how do you see, is that list so long that, I mean, yeah, where's the problem of not even changing faster, applying AI even more? Is it that the next things are already less beneficial and maybe they are not worth it? Or is it that people are not fast enough to adapt with things that you would try to make into use, or is it that the technology is not ready? Or where are the obstacles of doing it even not faster?
I think at the moment of speaking, we are at the stage that we have more ideas than people, and let's say, so I don't like, this is not in regards to people, but resources to build. So I think that's the concern right now, because so many things are happening, so many options are out there. And getting this 70% you can do quickly, but delivering this last 30%, this takes time. So I think it still comes down to actually having these resources to build it.
So some of the resources are things that you can try to increase, like hire even more people, of course, lack of talent and so on, but maybe hard to get those people. But in principle, that would be the direction to go. Get more people, get more things done.
You all have to keep in mind, if you get more people, then you have also a bit more problems, and getting this to work together just needs time.
Thanks very much.
Thanks.
Now I'm very happy to introduce Elena Sügis. She is actually at two places at a time, University of Tartu and Nortal. And we'll be hearing also about language models a bit.
Yes.
RAG was mentioned already. And some
Those
more
are
things.
the words. Those are the words.
Yes, floor is yours.
Thank you very much. So, yes, my name is Elena Sügis. I wear two hats. I work here in the Institute of Computer Science at the chair of data science, and also as a senior data scientist at Nortal. And yes, I like how Kristjan was setting up the scene today about the large language models and people involved and like what are the expertise needed and things like that. So we will talk a bit more on that part in this talk. And also a couple of people from our Nortal team are here as well. So make sure to grab them by the sleeve and ask more of what we are doing. So, okay. So here's a couple of words about Nortal. Nortal is a large IT consultancy starting from, consulting people, companies, and also implementing the solutions. And Nortal operates in North Americas, in Europe, and in the Middle East. One of our competencies is data and AI. So this is where I'm right now working. And in Nortal, I'm co-leading the Gen AI solutions development for various types of clients. Okay, so what I'm going to talk today. I will first of all introduce what are the RAG solutions, and we will learn about Nortal Tark. This is our offering. I will walk you through the case studies, so to say, success stories that we have built. And also, we'll talk about the challenges. I know that we have collected pretty many questions already here that were addressed to different speakers, so I will try to answer these as well, to incorporate them into my talk, because we have like really a lot of experience in these cases. So, okay, large language models and the generative AI has made a transformation of various domains. McKinsey, for example, shows that the adoption compares to the last year. Last year, the respondents, 33% of respondents in their companies, in their reviews, answered that they would use, they are recruiting Gen AI solutions, and now it's 65%. So it's a huge leap. Gen AI is generally transforming lots of domains. In terms of last year, you can see here on the slide, maybe here, that Stanford report has indicated 149 foundation models produced just last year. So it's really a large amount, and there are proprietary models. So the blue ones, there is like mixed license models, and the largest amount is the open source models. So raise the hands, your hand who doesn't use ChatGPT. So I thought. And so usually, correct me if I'm wrong, then we use ChatGPT for the solutions, for the tasks like, let's say, answer questions, right? Retrieve some information, maybe summarize some information, to generate text and explain context, concepts, and things like that. So in the enterprise setting, in the company or large organization, you would essentially want to do the same things. You want to answer a question, you want to summarize text, you want to find quick summaries of large documents, let's say. You want to generate text. In large organizations, there might be reports, for example. And as Kristjan also mentioned, in some cases, you want to convert unstructured text into structured database text, because it's more convenient to track this information afterwards. And usually, organizations have quite a lot of variety of collected digitalized data in conferences, in SharePoints, in their Google Drive, whatever, you name it. There are really a lot of unstructured data. And, we can talk about Nortal, for example. Nortal is like more than 20 years, and we have been collecting data for more than 20 years. And you can imagine like how, what are the amounts of this generated data, textual data mainly. And so, for example, if I want to ask, I don't know, a question like, can I bring the dog to the office in Estonia, or can I bring the dog to the office in Serbia? This would cause me a lot of pain, to browsing through these documents and searching. Most likely, if I would do just key-based word search, keyword-based search, then I would get a large list of documents, and then I have to look through them. And this is, I just want a quick answer. So, and in this case, maybe I want also to, if I have more sensitive question, then I want to receive links to the original documents as well, right? So, of course, ChatGPT is really cool, but what do I do with my with my company data, where I put it into that? There are a lot of limitations. There are a set of limitations. So if you're a very rich company, then you might have some specific model trained to work with your internal data. But usually, companies or large organizations, they have their specific knowledge bases or the collections of documents, and the large language model that you want to ask, it doesn't have the knowledge, right, about your specific domain or about your organization, internal information. So this is one limitation. Another is that large language models are basically frozen in time, right? So they don't update knowledge frequently, and in your organization, you might want to have this. So let's say you're frequently generating new regulatory documents, or you frequently generate, I don't know, reports, presentations, things like that, offerings maybe. So in this case, you want this information system retrieval to be frequently updated. And also, of course, there are computational costs associated with that. So if you decide to, fine-tune some model specific to your domain, it might be very expensive too. Yeah, and of course, additional layer of challenges, I would say, is the sensitive data. If you work with sensitive data, you don't want to just insert it into the prompts of large language models directly. And so the solution for these challenges would be something that is called retrieval-augmented generation. Well, essentially, you can think about it as ChatGPT with your own documents. And these systems would be, so in this system, we're sort of grounding large language models to generate answers based on the sources provided in our database. And so how we do it? Of course, we can separate it into two parts. Document ingestion and then context retrieval and answer generation. It is a bit more complex because, computers don't speak text, right? They don't speak natural language. So we need to, first of all, represent our data into numeric form, so numeric vectors. So first of all, this initial part of initial part was like this, that you first of all want to extract the context, textual context from your documents. Then you want to split it into smaller pieces. And then you want into chunks, and then you want to actually build the embeddings. So to say convert textual representation into the vector representation and store this into vector database. So this is the part where, where we transform our documents so that the models would be able to work with them. The next step would be to actually start generating the answer. And for that, we need, in retrieval generation systems, we would do as following, that the question that you're asking to your system would be also converted into the numeric form. And then based on this numeric vector and the data that is stored in the vector database, we will find the most similar vectors. And this is the retrieved relevant pieces of information that we some time ago put into our vector database. So, okay. And then what we do with this retrieved information, we put it into the system prompt. So this is the prompt that we give to LLM, which consists of, let's say, instructions to the LLM. Then you have this user query, so user saying what he or she wants to do, and also this relevant context that we have extracted. And so based on these given instructions, the model is creating the output. Okay, and hopefully user is happy. So this is the quick understanding of how this retrieval-augmented generation works. Okay, so pretty straightforward idea. Now what I want to show you is essentially what we do in Nortal. And like the Nortal Tark is a retrieval-augmented generation-based system, or like a set of solutions, a family of solutions. Nortal Tark is not a product because we create custom solutions for all of our clients. So, however, like the major idea, you get the major idea, is that usually such solutions are working using RAG architectures to ground the result to the sources of the company. Okay, so here are like three major, I'll show you like three major features, what we do. Naturally, the first option is, for what RAG systems are used, is questioning answering. And so here is an example of our web-based application. So this is like our demo environment that we play around with. And you can ask questions in different languages. You can choose the model which you want to use, large language models. And what it does, as you see, it actually, so when you ask something, the model starts generating the answer and also provides you a set of the original sources where the answer is coming from. So this gives the user a better understanding of the context, and a user can also evaluate the relevancy of the context. So if you don't trust this answer, you go and check. This is one idea. Okay, next thing is internal assistant. This is like rather chatbot solutions. The difference between intelligent search and chatbot solutions is that chat actually keeps the whole history of the conversation that you have. And it can be also used on the web, or it can be integrated into your, let's say, Teams, Microsoft Teams, if you would like to. Similarly to the search, you would start asking questions. The bot will fetch the information, summarize the information for you, and also provide you with the links if you want to have a look at the original sources. Okay. And the third one is, it's a document generator. It's coming from our own pain as well, because we are receiving like requests for proposals, these are called. And sometimes you don't want to, create it by hand all the time over and over. So you can actually use this document generator and generate these proposals by using the requests which are provided from the client. Okay, so that's that. And there were some questions about like which are the better solutions. Can you use it on premises? Can you use it on cloud? So for example, Nortal Tark, at Nortal Tark, we are LLM agnostic, meaning that our solution are using both proprietary models and open source models, and also these solutions, these solutions can be deployed pretty much anywhere. We have worked with a variety of cloud providers, and also tried out on-premises installations and hybrid as well. So when part of your systems is created locally and part is on the cloud. So these are the kind of cool features, I would say. What other things that I would like to mention here is that our clients are staying 100% in control of their data, and that our solutions are using AI guardrails, and we are also thinking about the quality of answers. So Kristjan has touched upon this topic a bit. We'll have a look at this a bit later here as well. Okay, so these are important things, I would say. Because when I joined Nortal, then there was no really understanding in the field of how do you actually evaluate the answer. And these are the very important challenges for our clients and the RAG solutions as well. Okay. So the case studies. So let's see like a few examples of what we can build, what we have done already. I can't show you all because we are limited in time, of course. But let's see. So what we can build. As they say that drink your own champagne, and indeed in Nortal we do that. This is Nortal AI assistant called Tark. Our main developer, Indrek, is here as well. He's waving, okay. So in Nortal AI assistant is internal tool to search for relevant information. And it integrates a number of various databases like Project Bank. We have Growth Hub, some proposals, and also some number of individual folders to get information from. Okay, and so here is a screenshot of how it looks. We have this integrated into our internal portal. It can be accessed from the web, so you can start chatting on the web with your Tark assistant and ask questions. Let's say, what kind of projects have Nortal done? I don't know, in North Americas or something like this. And you can also talk with Tark in different languages and receive, because in Nortal we are a multinational company, it's a group of companies, so we naturally need this functionality to speak different languages, including Estonian, which is really difficult. Okay, so not all the models are able to generate good answers in Estonia and understand the Estonian language. Okay. So I would say that the first, or one of the first really important projects that we have built, it was for Enstal. Enstal is world leader in solar panel like installations, and this was a project in North Americas. The problem there, I can go into the bit challenges maybe. The problem there was that company basically went through a series of acquisitions, and imagine that there are a lot of companies, and now they are becoming a group of companies. And all individual companies have this their own documentation, their own IT systems, and their own ways of or logic or how to keep the data for the databases and like how they store data. and handle it. And now the basic challenge here is that, or what they do, they install solar panels, right? How it happens is that a solar panel installer person is on the roof and is searching for some specific manuals, let's say. And so this, this is how he should get a really fast answer about this. The challenge here was not so trivial as we thought in the beginning, because maybe for some it is. So when we do the semantic search, then when we converted our text into vectors, then it's quite difficult to fetch information about product IDs. You know, like product IDs are really similar. Let's say it can be XYZ 1, 2, 3 or XYZ 1 to 4, right? And then like when we start searching for us or for large language models, it's pretty similar texts. But for installers, you know, like they need to find the correct correct manuals. So this was the challenge, and we solved it with something which is called hybrid search. So basically, we did the blend of keyword search and large language based model search. Yeah. Customer is happy. I would show you a couple of examples for Estonia as well. One of this project is the intelligent search and the chatbot solution for Chancellor of Estonian Parliament, Riigikogu Kantselei. These were the solution also that would allow employees or lawyers to find the documents quickly. One important and interesting aspect was that has been requested is that a person wanted to be in the loop, meaning that we don't completely search all the documents ourselves, but the users would pre-select the number of documents based on which they want to get the answer. So this is also some interesting feature of this solution. Okay. So Kristjan showed for the solution for the University of Tartu. We have built the solution for Taltech. And in here, the challenge was that there are, again, inside Taltech, although they have a pretty good structured data, but searching for the relevant information by the employees is pretty difficult. So you have seen the statistics, it takes quite a lot of time, or people just quit. So, but we want them to find the information, and we built this solution for them. What has been done is the intelligent search and the chatbot. And 25, so you can see here that we have integrated more than 25 databases. And employees have reported that they saved more than 75 hours of work per month. So it's quite a lot. Additionally, they got 3 times faster access to the information that they have been searching for. So very successful project, and we are also happy that we can contribute to the efficiency of our clients. Okay. Okay, so one interesting project about for the Public Health Agency of Lower Saxony, and this is intelligent healthcare crisis to solve intelligent healthcare crisis situation. Basically, it's a crisis chatbot. In case next COVID comes, then we want to not overload, healthcare agencies, but for people to communicate with this chatbot and find the relevant information. And the cool feature here is that you can actually call and receive information by voice into here. There was one question about previously about the locations of LLMs, and if you're Germany, then you're very strict on the type of models that you want. You don't want to use OpenAI models, which are the easiest, and here we had to experiment with variety of models and to choose a European-based model. Okay, So here is the third part. What to consider. So there are a lot of things, of course. There's like bias and ethical risks, data security, privacy, maybe variety of attacks on your systems, like when somebody tries to hijack your model or engage with in an ethical conversation with your model, something like that. Then there is a huge problem of how do you evaluate the quality of answer, meaning that how do you know that the system is not lying to you or it's actually providing you a correct, factually correct information. And the over-reliance of the systems and the regulatory compliance, I would leave this out. So what I'll show you is that the evaluation of the system actually depends on few parts. One part is how you pre-process the text, right? How you convert it, how you store it. Then what can go wrong is how you extract relevant information. So you need to check the problems, like a lot of problems might be here actually with your content extraction. And then the later part is the actual large language models answer generation. So in Nortal, we actually created, when I joined Nortal, there, as I mentioned, there has not been existing like good frameworks. So we have put our own methodology in place. And then later we have also adopted additional approaches that have appeared on the market. So what we do is we can do like end-to-end evaluation and also evaluation of the components of the system. And if to wrap it up like really shortly, then we use a set of, in our approach, we use a set of deterministic metrics and also model-based metrics. So model-based metrics are especially, I would say, especially useful in case you want to, only choose the model when you say that your retrieval part works pretty well, and then you go and evaluate your generative part. So what you typically want to do is assess factual correctness of the answer, right? The completeness of the answer. Has the system responded to all of the aspects of the system, of this question that user has been asking? You also would like to check how strictly your model actually follows your instruction when generating the answer. And also maybe like response match if you're using, if you're validating your model using a test set. Okay, here is one example from the project. What I would say that when we evaluate the answer, there is no really good, I'm having pressure. So there is I will wrap up quickly here. So there is no one good aspect how you evaluate the answer. I think our tendency to say either it's bad answer or good answer is not, as humans, this is not a really good approach, because as humans we also need to understand what are the good or bad different aspects of this answer. And so I would say that these model-based metrics are helping us also to think of different aspects of how good the quality is. Yeah, okay. I see that we have to wrap up. All right. Yeah, so, okay. Then we won't be covering the AI guardrails part in here. Yeah, but find me later.
Thank you.
Okay.
But let's take still a few quick questions.
When the chatbot lies, who is responsible?
Sorry, I didn't catch your question.
When the chatbot lies, who is responsible then?
Organization that is providing it. But so hopefully it doesn't. We want to, so basically what we did to catch this kind of use cases is to implement different evaluations for the development process and also for the product production phase. So in the production phase, you would also have a set of metrics that would tell you that it's lying to you, so you don't trust it. Yeah.
In the beginning of the slide, you said that these LLM models are like frozen in time, right? So you said in the Intel company you have implemented the your AI systems, tailored AI system. So my question is, let's say right now there is one manual which is being updated. For example, there is a solar panel that is out of order, so they are updated a new one. But the AI assistant is not the updated content is not present in that AI. So when the user can able to access that updated info, or in other case, so when this updated information will be available in this in that particular time.
So there are two ways of addressing your question. One is from the technical perspective, so that we have automated like updates through CRM systems, so that the system would, when you update your document, then it will be automatically ingested into database, so you have the latest. Another point of view is to look at it from the organizational processes, how your organization is handling such cases, if at all. So, yeah.
Thank you very much.
You're welcome. Thank you.
We've talked about many things. We talked about audio, we've talked about text, but there is an important modality we haven't covered yet, and that is vision. And I'm very glad to welcome Dmytro Fishman from University of Tartu and BetterMedicine company, and we'll hear a bit about vision, I hope. Maybe something else as well.
For a change sake, we will talk about a bit of vision. By the way, I wanted to mention that I'm also part-time senior researcher at Stack, just to be very clear about that part. Yes, I'm very happy to be here, and that is because I'm talking about better medicine here and there, bits and pieces all over the place. But I don't think I have had this opportunity to wear my completely better medicine hat for a longer stretch of time and talk about it in a more holistic and a complete way. So that's what I'm going to do, and I wanted to thank Meelis and organizing team for inviting me here. I will have both a bit of a company description, but I'll also tell a little bit about what research we do, and I will actually surprisingly align with some of our guest talk speakers here, both that just Elena just presented and also Tanel in the very beginning. But without any further ado, Better Medicine, we are a company which is aiming to make medicine better for everyone involved, including patients, families, clinicians, clinics, all the people, all the stakeholders. This is our long-term goal, maybe a little bit less realistic in the short term. And in the short term, we want to use AI and modern technology to transform the oncology diagnostics. So this is what we aim for. Now, we are an interesting bunch when it comes to founders team. So we are a blend of scientists, clinical doctors, radiologists, engineers, and entrepreneurs. This is what makes up the founders team at Better Medicine. We started as a company in 2020, in spring 2020, in the midst of the COVID-19 pandemic, when it was very clear, very obvious that our healthcare system is fragile and requires some update. And then in autumn 2020, we actually started to work, four initial founders at the wheel. This is the time we have set on our mission and the goals, and we actually got some very good first results from our first AI models. And then today we are talking, we are quite well funded, both from private sector but also public sector. We have received Enterprise Estonia grant. We have received one of the biggest European Innovation Council grants. which makes it possible to carry on our mission. We have by now finished one clinical investigation, and we are running a second clinical investigation for our AI models, and we are employer for more than 20 people. Now, we are operating in a cancer diagnostics field, and the problem there is that cancer very often is diagnosed very late. It's either incidentally found in patients, or it's found too late. When it's too late, then there's nothing that can be done. For example, kidney cancer is diagnosed, 60 or 70% of the kidney cancer is diagnosed incidentally, meaning that there were no special tests running for specifically kidney cancer. It was just found in the during the general diagnostics of the patient, which obviously makes this disease as deadly as it is. And no matter how much I would wish you all good health and your families, I know that by statistics, many of you have either known someone with a cancer or have been unfortunately diagnosed yourself. So this is the problem we're talking about here. And so this is on one hand. On the other hand, the very people who diagnose cancers and help us fight cancers, radiologists, they spend half of their time on repetitive tasks which can be automated. For example, 400 million scans done worldwide take approximately 50 million hours of work, and that work could have been either automated completely or could have been done more efficiently using modern technology. If that didn't sound too gloomy, I can make things worse. And the way to make things worse is to remind ourselves that the population especially in Europe, is getting older, and with older population, we have more cancer patients, which require more and more cancer-related imaging done, which actually increases the pressure on radiology workforce. This is one trend, and on the other hand, we have another trend, which is basically that the number of people that diagnose cancer, the number of trained radiologists, is decreasing. So the gap between the two trends is where Better Medicine is trying to make an impact. This is where we're trying to make a difference. How we do it? We are offering an AI copilot for radiologists. So we are building a system that can help them to detect, measure, and classify all sorts of lesions, not only in kidney, but also in the entire abdominal cavity. And we also take care of the disease progression. So we measure and we report the disease progression. And also we prepare and generate structured reports to radiologists that wouldn't have to write it by hand. So all this is something that we are building here. Obviously, we are talking about medicine. So one of the previous speakers had been from the bank. They could relate to that. So financial industry is very regulated, but so medicine is. So we have to validate every single thing we do with all sorts of regulatory bodies, and that requires real-world validation studies. So we do these studies with the hospitals we partner with. For example, we partner with local hospitals in Tartu. We partner with Pärnu Hospital. We also partner with hospitals from overseas, for example, Leeds Teaching Hospital, to verify, to build our tech in the first place, but also to verify that it works in real clinical settings. And we are proud of partner for University of Tartu in terms of research. So my research group, which is called Biomedical Image Analysis Group, we actually work together with Better Medicine to do research that otherwise the company wouldn't have resources to carry out. And I'll actually mention a couple of projects that we are doing together. Our product, BM Vision, as we call it, it's a package that offers radiologists a diagnostic viewer. This is the thing that you can see on the screen. This is called a viewer. This is basically a workhorse of the radiologist. They see the scan, they can scroll through the scan, they can make all sorts of findings, they can report, and this is what they do generally. But we also supply an AI-assisted tool measurement. This is something that can be done on the click. So they click on the finding and the whole process is automated. So the only manual input is their click. And finally, we have a suite of models, fully automated models that do sort of work that they do in the hospital. Later, they verify that they indeed did the right thing, but generally, they try to automate as much as possible. So when we are talking about these automated, fully automated models, we are quite proud that our kidney AI model, our very first baby, son, or maybe a daughter, I don't know, it's undergoing, almost finished with the CE marking. So we are probably very soon going to claim the very first in the world kidney AI model that is helping radiologists. We are super proud, it's a big thing. Our lung model is not too far behind. It will never be the first model because there are so many other lung AI models, but it's undergoing the CE marking as well. So we plan to add it into the package rather soon. Finally, we have liver and pancreas models working as a proof of concept, so not yet being validated, but in plans. And as a final touch is that something we plan to add in the future is the model that would monitor the lymph nodes. And this is the very frequent site for metastatic spread. So if any of you have heard about that, metastatic spread is something that cancers do, what actually makes it so deadly. So that was the part from the marketing team. Finally, some slides from myself as a researcher. A little bit about the technology that we are working with, something that we are building, including my teams. So here's I will start with the kidney AI model that is essentially doing something we call semantic segmentation of the CT scan. It essentially partitions the scan into kidney tissue, benign and malignant findings. That's the core idea. Once it has done that, we are measuring the findings and we are reporting them to radiologists so that they confirm them. Now, in order to validate this model, because as you know, as I already said, in medicine, everything has to be validated, including you have to prove and you have to build trust with radiologists. You have to prove that your model works. You have to actually show it. We have designed and carried out a very special clinical study for the local hospital in collaboration with the local hospital. We involved 6 radiologists from the radiology department, which have examined CT scans with and without our tool. And in this study, we were able to show that the AI model that we have developed helps to speed up radiologists by 33% on average, up to 52%. We were also able to increase marginally their sensitivity in terms of finding the malignant lesions, basically cancer. And we have considerably increased their ability to find cysts. And finally, we have also positively influenced their interradiologist agreement when it comes to detecting, basically classifying cysts and malignant findings. That is about the study. One reason why we'd like to measure the findings or would like to segment the findings is that in cancer, when somebody is diagnosed with cancer, they're often invited again to the hospital to do something called follow-up study. So now we have the original study and we have the follow-up study. So what is usually done is that radiologists have to look at both. And here's the place where a kidney AI model steps in. It segments both studies. It segments all the nodules in those studies. And what we do next is we have to align the studies. We have to put them in the same place. This is called a registration process. And this actually helps us to understand which nodules are which in the 2 studies, right? So we need to track the lesions, and that's what helps us to track the lesions. Then we measure all the relevant characteristics of the lesion. For example, we measure the size, the area, the volume of the lesion, and then we build a comprehensive report to the radiologist that use it to understand, to make a decision regarding the treatment. Now, what is complicated here, it actually is more complicated than it sounds. Because guess what? People do all sorts of tricky things between the original study and the follow-up study. For example, they eat unhealthy food and put up weight. Or sometimes they start to exercise, how dare they, and they lose weight instead. So basically, they do everything in their power to make the alignment complicated. And in order to solve this problem, we have applied and got the AIRE, AI and Robotics Estonia grant to build. We have some people who actually helped me to write this grant. I can't stand to, I have to say that thanks to actually Institute of Computer Science, we were able to secure this grant. We are building the AI model that helps us to build this kind of, this is called deformation matrix, and the deformation matrix is the tool that helps you to understand which pixels, or in our case, voxels, match which voxels in the follow-up scan. And that helps us to understand which lesions are which in the follow-up scan, and that in its own turn helps us to track the lesions. And this is the research we do at University of Tartu, at the Institute of Computer Science, thanks to the IRES grant for the BetterMedicine company. Now, a little bit more about other research things we do at Institute of Computer Science, what aligned with Tanel's talk is weekly supervised models. So, as you can imagine, building AI models in medicine is very complicated. On one hand, it's very expensive to train because you need to collect a vast amount of medical data that is very, very carefully annotated by very professional and high-paid people. They are radiologists. So actually getting their time to annotate data for training AI models is very expensive, and it also takes a lot of time. So ideally, we would like to avoid this at any cost. And one of the ways is through weekly supervised approaches. For example, you can easily acquire an image level label saying that this scan has a kidney cancer or it has a healthy person on it. So you have two classes. Now, what you do is you train a separate AI model, which we call a classifier, to classify scans into healthy versus kidney cancer classes. And then that prediction from that AI model is fed into another AI model. Suddenly there is another AI model, which is called a generative adversarial model that is a little trickster. And the whole aim of this other model is to generate an alternative scan so that to trick the first model. So the first model, if it correctly predicted that the scan contains kidney cancer, looking at this alternative scan would say, oh, I don't see any kidney cancer here, suddenly. And the way how this model, this second model is doing it is by generating a scan that does not contain kidney cancer. And this alternative scan, generated scan, is called a counterfactual scan. And this counterfactual scan, you can see on the image, it's actually this second one highlighted here. It does not contain kidney cancer. So when you subtract the original scan and this counterfactual scan, you get a mask or location of the kidney cancer. And suddenly, out of the blue, you were able to go from, oh, here's a kidney cancer on this scan, to a precise location of the kidney cancer, which you can now use for training your strongly supervised AI models. Here is just an image. How does this whole process, how does this result looks like? So on the left, you can see the original scan with the kidney cancer being highlighted by the contour. On the middle column, you can see a counterfactual example with the kidney cancer being removed by the generative model. And finally, at the right column, you can see the difference between the two. And the final project I wanted to mention here is about data synthesis, because there were so many discussions about synthesizing data. For me, this is what synthesis looks like. And actually, this is what synthesis for me looks like. What we do here is, again, because we're driven by this scarcity of the data, this lack of data, this is the most important motivating factor for me in the research we do in BetterMedicine, is because the data is very limited, it's hard to annotate, it's hard to get, it's very expensive to work with. So instead of really investing millions and millions into building vast data sets, we are trying to find smart ways to generate something out of what we have. And the way how we do it is that we use public sources. So this, for example, CT scan comes from a public database called KITS, where we basically try to alter the existing scans of the healthy people by ingesting tumors into scans. We're basically saying, hey model, can you generate a tumor in a place where there were none? And we tell it exactly where to generate a tumor. So here's basically a mask of a tumor that we want model to fill in. And the model is basically learning to do that. And this is how it looks like. You can see it on the very left side. I hope that I'm not mixing up the sides here. On the left side, you see the original scan where there was no tumor. And then there is this white area, and the white area is where we say, model, put the tumor here. Thank you. And then in the middle, you can see this is what model produced. This is how the actual generated tumor in the scan looks like. There is a purple contour just for you to see where the tumor is. And finally, on the right side, you can see this is the original scan. This is how the original scan actually looked like. So now we have the positional information. We know where the tumors are in the scan, and we can start building a model from here. Obviously, this technology needs verification, validation, everything that has been brought up by the previous speakers. I completely agree on that. And this is what we are trying to do here, is to build something out of nothing or very little, to be honest. This is the founders team. I told you this is a very interesting bunch. We have Kristjan Eljand, who is a serial entrepreneur building his third company. We have Chief Medical Officer Martin Reim, who is ex-president or vice president of the Estonian Radiology Society. We have people from experience with UK NHS system. We have my ex-Ukrainian AI student who has done some cool stuff with Microsoft, and myself as a scientist, and we have very experienced CTO. And that is pretty much it from my side. And I wanted to thank you for listening.
Many questions?
I have two questions. Dimo, very nice talk, and thank you very much. I want to ask you first of all about the synthetic data. What was the most challenging part in here? I mean, it's a bit trivial question, but it's a large question actually, because I see how much effort is here, and so what is the most problematic part? Like, why wouldn't you trust this data? Let's say it like that. And I will ask another question.
Thank you, first of all, for your talk. I didn't have the opportunity to say that. Secondly, everything is hard about it. What is important here, you may not see it because you're not trained radiologists. Maybe there are some among you, I don't know. Speak up, let me know. But basically, this model that we see here is a 2.5D model, which means it's not 3D model. Why is it a problem? Is that the slices that I'm just showing you here, they do not talk to each other. They do not know about their own existence, the existence of the other one. And that makes for very inconsistent picture of the tumor. Actually, everything in biology, because it's a 3D thing, it's very much connected. So this is not very realistic. We are now only starting to get some realistic 3D models working on this. And 3D, when you go to 3D, in AI ML world, everything suddenly collapses. Everything has been working in a paper, and then suddenly you just say, oh, let's add one more dimension, nothing works anymore. So that is the most problematic part, I would say. And the curse of dimensionality. I've been just giving, I don't know, probably there are some of my students from machine learning course, and I just taught them a lecture about curse of dimensionality. So CT images is a perfect example of the curse of dimensionality in action.
And one more question. You're the closest experts to ask this. It's not quite directly related to your work. So there are models that are able to do screening of lung cancer or early detection of lung cancer from the patient electronic health records. What about kidney cancer, renal cancer? Is it possible to detect this early from the healthcare textual data?
From the textual, you mean from the imaging data?
Actually, it can be both. One is like electronic health records from the, I don't know, blood tests, I don't know, some examinations when you go to the GP, whatever things. And then, of course, over your life, like not you specifically, but people, they do scans, right? And maybe it's possible to detect it somehow using previous scans too.
There are studies that show that you can detect kidney cancer from incidentally. So there are a lot of incidental findings in kidney cancer. So you can do screenings. There are very few screening programs out there. We are investigating, would like to be part of it. We are, by the way, part of the lung cancer screening program, or hopefully to be one part of the lung cancer screening program in Estonia. But the thing is, yes, you can do it. There are few kidney cancer screening programs. That is the answer for now. But yes, you can do it, for sure. That is a bit complicated, but yeah. Hello.
Hi. So I also had two questions. The first one, when I researched the cancer diagnosis, there is the reason why the lungs are the first models, because it's the most deadly one. And unfortunately, I didn't read how deadly is the kidney one. So why did you choose kidney?
It's easy. It's not the deadliest cancer, but it's the one that we had access to data and we were able to generate AI models. So that was just an easy choice. It was in a way for us, it was a low-hanging fruit. We didn't see other kidney solutions out there. So now we can claim with the pride that we are the first kidney AI model, and that's it. Yes, it's not the deadliest, but who cares? We are the first.
Yeah. I was not in the talk about the dimensionality, but would one possible solution would be to give the stable diffusion model like context from the previous images they generated, and they can use it as a context to fill the next layer.
Yeah, that's what we do. That's what actually, that's what we are trying to do. You're absolutely right. We are basically fitting in the previous images and saying, hey, generate something that would look very similar to this one, but not exactly. Come and talk to me. Maybe we want to work together. You seem to be on the right track.
Hi.
Hey.
Just a question. Why not extracting the kidney, for example, and after, changing it or working on it?
Are you asking a question about synthesizing data, or are you asking a question about detecting the kidney tumor?
Both.
So the thing is, extracting kidney seems like an easy peasy task. It's not. In a way, we can do it quite decently with a good, very reliably, but sometimes it fails. And relying on other strongly supervised models to train your weakly supervised models is like a little bit of a stretch. So we are trying to not anchor ourselves on other supervised models to build something else. But yes, this is one idea. What we do is something in between. We are like basically filtering out regions which are probably not kidney, definitely. So we are kind of similar in there.
Thank you.
It seems I have the honor of asking the last question. So eventually it's the doctors who make medical decisions. So you mentioned trust already. So, we all want to build better and better AI models, but there is also, in one way, it can be risky to have too good of a model, because the doctor starts to trust the model more and more and might kind of switch off mentally some of the criticism. And so a better model might eventually end up with some wrong decision just because every model makes mistakes, but now suddenly the doctor is not paying enough attention. So what's your take on this?
That is a serious problem indeed, and we also saw it. It can be solved by like an assemblance of different methods. You're not doing it once, like in a one way. There are a lot of different approaches how you do it. One way is that we always remind them that you're the final decision maker, right? Are you sure? Is there everything else that you checked? Everything's fine. Another way is that we have to make sure that the model, even If the pilot is drunk, the plane will land safely. That is we have to do it. This is just no way out. So we can't afford to have a model that just does gibberish. We have to do it so that the model is performing well, even if it's unsupervised, but also trying to poke and trying to encourage as much as we can doctors' attention, reminding them that they are the final decision makers, that they are the final responsible for the well-being of the patient. At the same time, we have to do our job as good as we can.
Thanks very much.
Thank you.
And before we get to the snacks and drinks out there, some more important things. So first of all, thanks very much to all the speakers. Thanks very much to all the organizing team. So Caroline and the industrial collaboration team, and Lotte and the PR team, and IT Comp for helping with all the technology that you see here. So big thanks to all of them. Thank you for coming, but the data science seminars will continue, and AI is certainly very hungry for computation, and so computation and high performance computing, and not only AI, but there are many other things that need to be computed. So the next data science seminar is going to be held on 26th of November about high performance computing. So I hope many of you will be here. Thanks very much, and enjoy the evening and networking.